Okay, chapter 15, there was one piece that was left off of the day one video, and I just want to add it to your chapter 15 notes. And so there's two things that I want to talk about. One is sample space. Sample space is a list of the possible outcomes. So someone's going to give you an event, and then you list all the possible outcomes that could happen of the event, and that is your sample space. So for example, if you flip a coin twice, what's the sample space? Well, if I flip a coin twice, I could get heads and heads, or I could get heads, tails, or tails, tails, or tails, heads. This is my sample space. It's just a list of all the outcomes. All right. The other thing that I wanted to put into those notes deals with what I call Venn diagrams. Now, we talked about Venn diagrams briefly in chapter 14. We use Venn diagrams in chapter 15 when we have situations where we have two events in which you're given the probability of both events happening. You get probability of this, probability of that, and the probability that they can both happen at the same time. So a this, a that, and a both. If that's the case, then we're going to make what's called a Venn diagram. So for example, in a class of students, 40% are boys, 20% have blue shirts, and 5% are boys that have blue shirts. So boys and blue shirts. So we make two circles that intersect. We label one of the categories, boy, the other one blue shirt. And we always fill the center in first. So 5% are boys with blue shirts, and I use decimals, so 0.05. Now, what else do we know? 40% are boys. So here's boys. This circle has to total up to 40. I already have 5 here, so this outside piece has to be 35. 35 plus the additional 5, now I have a total of 40. This number will never be the original total when something is here in the middle. So if something is here, you got to subtract it off of the total to get the remaining piece. These are just boys that don't have a blue shirt on. They have some other shirt on. Blue shirt. 20% have blue shirts. I already have 5% here, so 15% are kids that have blue shirt but aren't a boy. So now, what's the probability that a student is a boy or has a blue shirt? Well, that's just the sum of all of those pieces. 0.35 plus 0.05 plus 0.15. So 35 plus 5 more is 40, plus that is, plus 15 is 55%, or 0.55 probability. Okay? I could also calculate, if I wanted to, the neither. Like what percent doesn't have, is not a boy and is not have a blue shirt. Neither boy nor blue shirt, and that would be 1 minus this. Gives me this piece in here, which is 0.45. Hang on one second. So that's the neither boys or blue shirts. And we use this to answer all sorts of questions, but again, the question has to be a percent of one thing, a percent of another, and a percent of both. And if that's the situation, then that's what we make as the Venn diagram.